So we are recording this. One of our girls is not here and she was very keen to hear about chemical engineering. So we are recording today.
Hello. Lindell, can you hear us?
I can hear you.
Okay, perfect. Are we waiting on anybody from your guys' end? Looks like I have all my crew here.
You have everyone? Okay. We may have one or two girls pop in who are running a bit late, but they'll just join in as we go. It is lunchtime here in Australia, so we'll probably be eating while you guys talk. So I'm sure
Sounds great.
Fine. All right. So I'll just move out of the way and
so perfect. So we set up a interview panel tonight for chemical engineering for you guys to learn more about it. I have some questions queued up for the discussion, but if you guys have any questions, please interrupt me. This is for you. So I want to make sure that your guys' questions are answered before any of mine are. And so on the call today, we have myself, Nicole, although it says my name is Sweet ETI, so maybe I should change that. And then we have 3 ladies from a company called P&G, and they'll explain more about what their company does. But we have Nicole, Rhea, and Rachel on the call today. So before we kick off with any questions, I'll just have you guys introduce yourself, and I'll just call out who should go first so it doesn't get confusing and everyone tries to talk at one time. So Nicole, if you want to go ahead and start, just introduce yourself.
Sure. Yeah. My name is Nicole P. Sierra. I work at Procter & Gamble currently. Rhea actually doesn't work at Procter & Gamble, but we'll hear her story in a minute.
Yeah.
So I have a little bit of variety. But me and Rachel work together. So I am chemical engineering. So I'm in the right place, I hope. And I graduated with a chemical engineering degree in 2017 from the Colorado School of Mines, which is in Colorado. It's in the name. And yeah, I've been with Procter & Gamble for 3 years now, and currently in a, they call it like a tech hub role. So it's pretty much like innovation, like new initiatives that come to our manufacturing site. And our manufacturing site makes Oral-B toothbrushes. So if you've ever used an Oral-B toothbrush, they come from our site or some of our sister sites. So yeah.
Okay, Rhea, if you want to go next, since I messed up where you work at.
Oh yeah, no worries whatsoever. So I'm actually a senior process engineer at a company called Global Foundries. And what we pretty much do here is we make the chips and the circuits that kind of go into our phones, into our computers, into Xboxes and things like that. I studied chemical engineering from Iowa State University, and I graduated in the end of 2017. I've been working here for about 2 years, and I really like it. So,
Awesome, thanks. And then Rachel, you can go next.
Sure. So I'm Rachel Morris. I studied chemical engineering as well, and I also went to Iowa State, which is in the middle of the Midwest in farm country. And that's where actually all 3 of us live right now. And I graduated in January of 2016 because I did like a co-op, which maybe we can get into some of the detail, but it's just basically like a longer internship. Instead of just the summer, you actually do a semester and a summer together. And I've been working at P&G for about 5 years, and I, like Nicole, do innovation work, but I work at the shampoo and conditioner facility. So it's a completely different process because we're basically mixing a bunch of raw materials in a big giant tank. So think about a tank that takes up the whole room that you're in right now. That's the size. And so we get to basically add some cool fragrances and different dyes to make the shampoo the look that we want for our customers to have.
Awesome, thank you. I'll just dive in and ask some general chemical engineering questions so that you guys can understand a little bit more about what chemical engineering is. And then if you guys have questions, we can ask more specific ones in a bit. So can you just start off by explaining, again, what chemical engineering is and give us a background of what this type of engineering involves, and if there's anything in particular that you can bring into the conversation from your previous experiences to just give an idea of what exactly chemical engineering is. So Ria, if you want to go ahead and start first.
Yeah, sure. I was thinking of a few examples, and one of the things I can think of is with this entire COVID pandemic, right? One thing is it might be a chemist or someone like that who actually makes the vaccine. However, when it comes to chemical engineering, what we kind of do is we are the ones who will be figuring out how to scale this up to make doses for hundreds and millions of people, So there's going to be a process that's necessary to create it and things like that. And it's going to be a group of engineers and chemical engineers included who figure out how exactly to get that to work, So more often than not, it's going to involve a process that needs to be figured out how exactly to get it most efficiently and how we can be able to get as much of the product as possible. Mm-hmm.
Cool, Rachel.
Yeah,
Go ahead, Nicole.
Yeah, I know. I was totally going to agree with Ria. I think the question that we get a lot is what's the difference between chemistry and chemical engineering, right? And I think the difference, just like she said, is scale. So if you think of chemistry, like you're making something, like maybe you're crocheting a hat or something, right? It takes you hours and hours to make this one hat, and then you get really popular and you're like, oh, how am I going to be able to do this more and bigger and all of that? And that's the same idea, right? Is that something that we can do in a small scale may not be able to be mass produced or to be, distributed on that scale. And so that's really what we do is we take those, it can be, in some cases it is like base, maybe it's a vaccine, or maybe it's something small, maybe it's a toothbrush, maybe it's shampoo. So really anything that needs to be scaled up, that's when you bring in a chemical engineer.
Mm-hmm. Exactly. Yeah.
Yeah. And so I'll just add a little bit more. So, and kind of what makes chemical engineering special is we're really looking at different reactions. So I'm sure you girls have done some different like science experiments where maybe you're mixing, like just think of like mixing vinegar and baking soda, how that can make a lot of gas. And so you can imagine if you do something like that on even bigger scale, how do you capture that gas, or how do you like prevent that reaction from going out of control? And so that's really what chemical engineers are responsible for. We're very conscious about environmental regulation, so making sure we're not putting any pollutants in the air. That maybe on a small scale, like if you're doing it in a chemistry lab, it's not a big deal. But if you're doing thousands upon thousands of this reaction, you can imagine how that could really impact the environment. So chemical engineers are really focused on not only the scaling up the process, but also making sure that it's safe and that we're meeting governmental regulations. Yep.
Cool, thanks. And then can you also explain how chemical engineering is different from other engineering disciplines? So we got kind of a background of what it is, but really focusing on like how it could be similar or different compared to all the other engineering disciplines out there. So Rachel, if you want to start.
Yeah, so like I mentioned, chemical engineering is really focused on more so reactions. So the biggest reaction that I remember learning about in school was fermentation. So does anybody know what that is? Yeah, so it's like making wine or beer. And so when you think about it, it really is a chemical process that's using a microorganism to do that. And so really that's kind of what, in my mind, what sets apart a chemical engineer from maybe like an electrical or mechanical is you really understand the chemistry behind what you're doing. And so you can kind of add your knowledge to make the process better.
Ria or Nicole have anything to add to that?
Yeah,
oh, go ahead, Ria.
No, it's fine. All right. Yeah, I think in general, just like we were talking about, one of the biggest things about it is that we use a lot of these chemical reactions to be able to figure out how and exactly we can use that as a product, you know what I mean? And so that being said, we are able to use, we have the fundamentals of using that chemistry and the reactions and things like that. So I think that's really what makes the chemical engineering aspect of things.
Yeah, and I think even, you know, in some things like in toothbrush making, for example, chemical reactions it's not a huge part of what we do. But they really do bring in chemical engineers because we really understand how to look at a process holistically and how to see the inputs and outputs of a process, how to make those more efficient, how to make those safer, how to make those. So even if it is like a piece of equipment that's doing something physically that you would like, a mechanical engineer might know really well the individual parts and how the individual parts react and that kind of thing. But a chemical engineer can look at the entire machine and say like, oh, I'm getting this defect on a product. Let's go back and see what could be affecting that from the beginning, from the start of production. So it's really looking at like, and I think Ria said she was a senior process engineer, and me and Rachel, I think Rachel started as a process engineer too, didn't you? Like, so, but we all started kind of, or are process engineers, and it really is very much in line with what chemical engineering is looking at a process and being able to optimize and affect it.
Cool. Thanks, guys. I'm gonna pass this off to the girls and see if do you guys have any questions for them right now? If you don't, I can keep going, but open to your guys' questions.
What's your favorite part of chemical engineering?
Sorry. Favorite part of chemical engineering, right? Okay, yeah, Nicole, if you want to kick it off.
Yeah, I think my favorite part is just how applicable it is to a lot of different things, especially manufacturing. But I love watching like how it's made. If you've ever like watched a how it's made episode and thought this is the coolest thing ever, you probably should be a chemical engineer because it's really that you can really walk into any process, or for me, any manufacturing plant, and just pick up on all these things that are happening that are like, I know that, or I understand that, or I can see where this is going, or how this connects and what it's going to make. I think that's really cool, is to be able to walk into any situation, look at it, and be able to, deduce what's happening or what could happen. So
I think the coolest thing is that no matter what happens, there seems to be like a lot of problems that can come up, and a lot of really cool challenges that can actually be solved using chemical engineering, So just like Nicole was talking about, when it comes to processes and things like that, you can figure out what exactly might be causing an issue just by looking at what might have happened a few steps before or something like that, And so just seeing all of those challenges and being able to kind of like get through them and work through them with the knowledge that we have is like really cool.
I think I can kind of play devil's advocate and kind of answer the question in a different way. So for me, I really don't see chemical engineering be as big of a thing for myself as much as just engineering in general. So I think you can't go wrong if you really love problem solving and you really just want to dive into why some sort of issue is happening and you want to understand why and how it works. You really can do that with any discipline, whether that's chemical. Because actually for myself, if I would have done it over again, I might have actually picked electrical. But, I think where I'm at right now is where I'm meant to be. But I think you really can pick whatever you want. Mm-hmm.
Looks like we have a question from Gretchen in the chat. She asked, how did you realize chemi was the right path for you? So why did you pick chemical engineering in the first place? What drew you into it? And then Ria, you can start.
Yeah, sure. So chemi is one of those engineering fields which actually uses things that we learned in chemistry, you know, so things like maybe a rate of rise equation or chemical equilibrium. These were fun things that I really liked learning in high school and things like that, you know. So I knew I loved chemistry, and chemical engineering was one of those places that actually applied that. And I still use that stuff in my life, you know, and I use that in my job. So I really like it. And that's how I figured out that it was the right path for me.
I can go next. So for me, chemical engineering was the most versatile. And so I really didn't know what I wanted to do when I got to college. I was like, I don't know where this is going to take me. But through my different internships, so I actually, like, as a chemical engineer, I got to work on rockets one summer. And another summer, I got to do research on biomedical technology. And then another summer, I made corn milling at a facility. So kind of the consumer goods from a food standpoint. And so really to me, what stood out and why I picked chemi was I was like, I can go anywhere and do whatever I want. Because you can also go into like kind of renewable fuels or like biofuels and that kind of stuff too. And so for me going into college, I was like, I don't know what I want to do, but I felt like it was a pretty broad major.
Yeah, and I think for me, I was with Ria. I knew I liked chemistry from high school. It was one of the classes that really clicked for me, and I just really enjoyed it. And through my internships where I did more chemistry related work, so doing more like research in the lab and that sort of a thing. And by doing that, realized that that was not for me, and that I wanted to be out on the floor. I wanted to be doing stuff. I wanted to be doing equations. I wanted to be interacting with people. And like, I think research is an incredible profession, and it just was not the pace that I wanted. I wanted something very kind of active. And I found chemical engineering through other internships and things that chemical engineering led to more of those kinds of career paths. And then I found with P&G is that's exactly right. Like, is working in a manufacturing plant as a chemical engineer is, you know, very active work, very engaging, like constantly changing, constant challenges all the time. But that's what I thrive off of. And so I think I ended up at the right place from trying different things, but ultimately knowing that I liked chemistry as a fundamental. I just didn't know what I wanted to do with it.
Great. Are there any other questions from you guys?
So I've seen all those satisfying videos of production lines. Are they as satisfying in real life as they are on YouTube?
Yes, even more so. I think watching manufacturing lines is one of my favorite pastimes. I think that they just, and part of what we do as engineers, not just chemical engineers, but engineering in general, is creating that repeatability, creating something that we can make 100 million times in a row and it happens the exact same way every single time. And that's what gives you that feeling of like, like the label's going on the bottle the same way every time, you know, and those kind of satisfying videos, like that's kind of what we get to work with every day, is making sure that that happens and that the product that comes out on the other end is as good as we want it to be, right? That's the standard we're headed for by doing that process over and over and over and over again. So yeah, I would say so.
Yeah, it's a lot of fun actually being able to see that on the production line. Exactly. Being able to see it repeated. It's like magical almost, you know, like you can almost see it go down the line perfectly. And yeah, it's really satisfying too. Mm-hmm.
Good question. Do you guys have other questions?
Anyone else? Right, take your mask off. Yeah. What is the hardest part of chemical engineering?
Take it away, Rita.
Yeah, I'm thinking. I think sometimes, at least when you're on a manufacturing line and things like that, one of the biggest things that is that can be a little challenging, that can be a little tricky, I guess you can say, is everything is very time dependent, you know? And so things can be fast paced, things can be really quick, things can be, what's it called, coming right at you. But that's how you learn, you know? And so when you have a lot of those things coming towards you, it can get a little challenging at times, but those are the things that kind of make a day exciting as well. So when we think about it that way, I think that would be the most challenging thing, I guess you can say, that I've dealt with, you know, as a chemical engineer or process engineer. Mm-hmm.
Yeah, I would say for me, the hard part is having to deal with conflicting priorities where you might think that this kind of improvement might lead to this result, but you might have either another peer that disagrees with you, or maybe your boss disagrees with you. And you kind of have to like work through it together as a team and say, you know, maybe we disagree on this, but let's try it your way, let's try it my way and see which way is better. But sometimes that can feel hard when there's that conflicting opinions on what to do next. So working through that can be a little challenging, but usually by collaborating, you come to the right decision.
Yeah, I think for me, the challenging part is, I think that in the field that I work in, making toothbrushes, and like I said, it's not a very chemical heavy process, is that like my expertise with the chemical side of it doesn't always apply. I think that can be hard because I didn't really have any background in mechanical or electrical or all these other things that in hindsight, I'm like, I wish I would have taken a class about, you know, mechanical engineering or even just tool, you know, something very, very like that. And so sometimes that can be challenging, is like, we're looking at an equipment and something isn't fitting together right. And they're like, you're the engineer. And I'm like, I'm chemical engineering. This is not a chemical. This is a bolt. Like, so I think that can get frustrating sometimes, but you have to really like hone in on your problem solving side of engineering and try and apply that to different situations. But sometimes you're like, just give me a chemistry problem, I could solve that for you. Like,
Other questions that you guys have? Sorry if you hear my dog in the background, she's going a little crazy.
I don't think we've got any more questions currently, but we might need it.
You say that's all the questions you have for now?
Yeah, for now, we might have some more.
Okay, yeah, just feel free to jump in, and if you can also type them in the chat too, if that works better. Either way. So my next question is, can you walk us through a day at the office, or maybe a combination of days that a typical chemical engineer, or maybe just an engineer in your position, goes through, and then what exciting things are happening?
Compared to some of our team, they actually get there at like 5. Some people even like getting there at 4. But the nice thing about my job is that I have a lot of flexibility. So usually when I get in, our team sits together and we call it a daily direction setting meeting. But basically it's everybody get together, see what are the issues that we have that we're working on for the day, and who's going to be tasked to do which action. A lot of my work comes from understanding what are the quality specifications that we need to meet in order to deliver a new initiative. And so when I say a new initiative, what that means is either a new formulation of shampoo, which you'd be surprised how many formulations of shampoo we have out there, or it could be a new package design. So maybe instead of this bottle that's about this tall, we want a bottle that's this tall. Or sometimes we also just have different configurations based off of what our customers want. So Walmart, you can imagine is more of like a smaller size bottle, while in the US we have like Costco, which is like as big of size as you possibly can get, right? And so in those innovation projects, I lead basically from the beginning of the concept to the execution actually happening on the production line. So that involves getting change parts from the line, which are basically tools that we use to be able to run that size. It also involves getting the right materials. So the new bottles that are coming, or the new perfume that we want to add to the shampoo. And it also involves making sure quality is aligning to all the project work that we have going on. So throughout the day, I'm normally meeting with each individual team to understand where we're at in the overall project. So that way we have our materials on site. before the line tries to go and run the materials. Because you can imagine if we don't have everything and we're ready to start up the line, that's going to cause issues. So a lot of my job is kind of being the communication point and understanding the whole project scope. So that way, if somebody comes to me with an issue, I can not only address their issue, but understand what are the ramifications if we miss a date that they were supposed to deliver. What does that mean to the rest of the team? And so a lot of my job is talking, talking, and really problem solving from a whole strategy standpoint. So understanding the project end to end, and thinking through any problems that come up, how do we fix them? And then what do those solutions mean?
That was a lot of information. Really appreciate it. Nicole, you want to go next?
Sure. So me and Rachel have very similar jobs. So I think she did a beautiful job describing it. So I'll kind of tell you about the role that I had before this. I was a team leader, which for us is when you are assigned to kind of manage an entire team. So I had a team of people who, if you look at a manual toothbrush, they run the equipment that puts the bristles into the brush. So we have an entire organization. I think there's about 30 to 40 people on my team. There's about 30 to 40 pieces of equipment. And we would come in the morning. So it was a 3-shift operation. So I would have team members on 3rd shift who they would end at 7:15 in the morning. So I would usually come in like 5:30 or 6, just so I had time to be with my 3rd shift team. And then just like Rachel said, we had a daily direction setting meeting with my 1st shift team and then with my leadership team. And we discussed what happened in the last 24 hours, looking at all of the data of how each piece of equipment ran, what were some of the biggest issues, what were some of the bigger defects that happened, was there any quality or safety alerts, anything like that happened, and then setting a priority for that day. So is there something new we need to run, or is there some training that someone needs to do, or do we need to make a plan for our weekends, or whatever the goal is for the day. And then I would spend a lot of time coordinating between my team of technicians, and then also we have like mechanical resources, so like electrical leads and like tool room makers, like things like that, who assist with the operation and kind of coordinating between them what needs to be done. And then sometimes I would spend 2-3 hours at a specific equipment that's having more trouble than the rest, and just kind of being a resource and a sounding board of, okay, what do we try now? Like, what do we do now to try to get this up and running? And with manufacturing, the biggest thing that we focus on is not only safety and quality, but how can we get the machine running more efficiently? How can we get it up and running as soon as possible? Making sure that it's always running. And then things like that during the day. So not only managing people, but also managing equipment and managing, what product needs to go out the door today. So we have a huge order from Walmart and we don't make sure that we're producing the right thing that they need, then that's a very unhappy customer, and that's not what we want. So managing the schedule. So it's a good balance of the technical aspect, and then also like some more soft skills like managing people and schedules and that sort of thing. And then my 1st shift would leave at about 3:15, and then my 2nd shift would come in, and I would work with them for a couple hours, and it just kind of went like that. So it's very much data-driven work, as in this is what happened yesterday, and that's going to create a plan for us tomorrow or today. So.
Cool.
It's
Thank
actually
you.
really cool to, sorry.
No, go ahead.
Yeah, it's actually really cool to hear both of that, because both of you guys say that, because I work at a completely different company, but the day starts pretty much the exact same way,
Oh, that's crazy.
Yeah, exactly. I think it's the fact that generally when we're working in these manufacturing realms and stuff like that, there do tend to be like 2 or 3 shifts, depending on what sort of plant it is and things like that. And my day would also start with a 7:30 meeting, and that one would pretty much tell everyone how exactly did things run last night? What were the problems we had? What were the issues that we faced? What of those needs to get first priority? What of those need to get like second priority? What are those things that we can put on a project list and kind of like make it bigger and bigger and bigger and pretty much solve it from the start, I guess you can say, rather than having to sort of firefight and have to specifically figure out what exactly we need to do to optimize a process, you know? So first, it would be, what are the major problems that we'd figure out what are the major problems that we've pretty much dealt with? Is there something we can do right now to fix it? And is there something we can do even as a process to make sure it never happens ever again? So I might work with teams that are within my own team to figure out, hey, is it my machine or is it my type of machine that kind of created it? Or is it another type of machine that I know occurs, has a process, maybe like 2 or 3 steps before this. Maybe I can talk to someone on that team and see if this is normal and things like that. So it's kind of trying to figure out what problem might occur before it even happens. So it's kind of like mind reading. So it's kind of cool too that way. Mm-hmm.
Yeah, being proactive and identifying risks is a big part of engineering. You want to make sure you catch those before they happen.
Mm-hmm.
So we have another question from Gretchen in the chat. So her question, I'm gonna read this word for word. She says, I despise working on computers and want to avoid a career with lots of staring at a screen. How much time do you spend working at a computer in a day? So I just want to first answer this by saying you probably should not do computer engineering or software programming. You'll be on a computer all day, but something with manufacturing would likely be more your speed. So I'll let them answer the question. Nicole, if you want to start.
Yeah, I think the cool thing about manufacturing is that you can kind of balance between your computer work and your on the floor work. And I'm the same way. I don't like, staring at a screen all day. And I think with my current role, I have a lot more connections with people outside of the plant, which I enjoy. So getting to work with people from our our marketing team, getting to work with, the people who design the artwork, the people who are designing the brushes, and like, how do we work on a project together? But also we are the execution team on the site. So if, like Rachel said, I have a new material coming in, that means that half the day I'm on the floor at my machine that's running that material validation and kind of doing that hands-on. So it's a good balance of, if there's some days where maybe I'll spend the whole day on the computer, and then there's other days where I probably won't sit down. It really just depends. And I think manufacturing operation kind of gives that kind of back and forth, is that you have the hands-on side of it too, that you can go and work on all day, or, some days you might not. But I'd say probably like 50-50. I think with COVID, it's upped a bit because the people that I used to meet with in person who are on like in my site, we have to meet virtually, even though we're in the same building. So I think that's a little bit of a skewed data. But that's just kind of the reality right now. So.
Yeah, I agree. I think it's about 50-50 for me as well. What would tend to happen is generally I try to structure my days in the sense that in the morning, if I have any computer work, I can kind of get that done with. And in the evenings, I'll generally, or after lunchish, I'll pretty much go down on the floor, get with everyone, see how the machines are working, and see if any help is needed. Work with them on troubleshooting on problems right there and there, so it's a little bit more hands-on that way. And I try to structure my day that way, but 90% of the time it doesn't always work that way. And there'll be changes based on the schedule. There'll be changes based on the priorities of that day. And so one day it might be that I'm completely on the floor and I'm helping out with a major issue that's going on. Another day I might be more at the computer analyzing a little bit of data of some tests that I ran, of some experiments that I ran. So, but in general, I would say it's about 50-50-ish. Mm-hmm.
Yeah. And so that's kind of more of like a process engineer. And just this is not specific to chemical. It is applicable for mechanical or electrical. But if you decide to do, so say you don't mind computer work, which is more like what I do, you can also do like project engineering, which is really like a lot of computer work up front. And then it leads up to an execution of, call it like a huge construction project. So maybe the plant has decided we're going to build this brand new packing line or brand new making system. So you can imagine we're going to open up the ceiling in the plant. We're going to drop some tanks in, and those are going to be our new shampoo making system. And so what's cool about a role like that is even though you do all this computer work to build up to it, when it comes to those 2 weeks of construction, you're going to be nonstop, just on the floor, working through different issues as your different like millwright workers or your electrician workers. They're trying to plug everything in and get everything setted. It also, you can involve concrete work. And what's cool about that is you're working with a lot of different construction guys and getting to experience that. And then you have those kind of like 2 hardcore weeks where you're just all on the floor, all hands on deck. And then you get to see the system start up, and maybe that's a couple more weeks of work. And then what's really cool is like, you're like, dang, all that work was worth it. And you walk away. But I totally feel you, Gretchen. Like I started off and I was like, I never want to touch the computer. But what's cool about engineering too, is you can ebb and flow between those two, right? You can do a more process engineering role where you're really just looking at the process. All you're using the computer for is analyzing data. Otherwise, you're on the floor looking at it, watching it run. And then you can ebb to the other side where it's like, okay, you're mostly on the computer, and then there's these huge downtime events where you're feet on the floor for a couple weeks on end, and then you go back to the computer work.
Awesome. Thanks, guys. Are there other questions that you guys have? No? Okay. My next question was if you could share a time that you failed in your job and what you did afterwards to overcome this failure. So we know that not every day is great and we make mistakes. We're not perfect. We're human. So mainly focusing on how you can overcome failure if you do experience what you will at your job, but what you do in those situations. And I know this is a tough question, so whoever's ready to answer, you can let me know.
I guess now it's funny, but at the time was not funny. As one of my very first like tasks when I was a process engineer is a big part of what our company is doing, and I think a lot of companies is something called digitization. So the idea of taking data and digitizing it so that it's available on like monitors and screens and on iPads. And so like operators are able to be running their equipment and they can look on their iPad and see exactly what their process settings are, and not have to go to every single line, read it off their screen. They can look at 6 lines at the same time. And so one of my tasks was to actually mount these giant televisions like on the ends of our equipment so that we could have that data, like live data all the time. So we could walk past and see how the machine is running, what's our PR, which is just it's a term for like how well it's running, more or less. And so I was like, okay, I can mount a television. That can't be that hard, right? And so I was working with a millwright and who does a lot of the work with the equipment. And he was like, all right, you tell me, draw on the machine, tell me exactly where I need to like drill. Just tell me where to drill. And I was like, okay, this is easy. I just graduated chemical engineering school. I can tell you where to drill. That's easy. And so I had if you imagine putting a television on the floor in front of you and drawing on the back, this is where all the plugs are. So this is where I need to cut holes. This is where I need the drill. And then I lift it up and I put it against the equipment and I say, here, and here. And this piece of equipment is probably $4 million. Let's just be clear. And so he drills the holes and we go to hang the television and realize that I had mirror imaged it and all the holes were on the wrong side of where they needed to be. And there were giant holes in the back of the equipment where this TV was supposed to go. And he looks at me and I look at him and he's like, well, what do we do now? And I was like, oh my God, I don't know. And so that, I don't know if that, I guess it was a failure in a sense, but they were really good about it. They knew I was, new and I was freaking out and everything. And so the millwright was able to just make me a new, like a metal backing for the equipment, like a new piece of metal to replace that one that had all the holes in it. And then, we went to do it again and he's, joking with me. He's like, let's make sure and double check it this time. And I was like, never again will that happen. So, like I said, funny now, but I mean, those little things happen all the time where you just get overconfident and forget to double check your work. And next thing you know, you've mirror imaged it and cut into a $4 million piece of equipment. So there you go.
And the important thing is they didn't fire you, so you can make mistakes.
They didn't fire me.
Move on.
Example for you.
Yes.
So this bottle, so this is Herbal Essence, which is a super popular brand for, we call it like teenage girls, but I even use this stuff. I'm no longer a teenager. But what we decided to do with this initiative, and I hope it'll come up on the camera, is you see these lines down here? So these 4 vertical bars. So we use a laser to burn onto the bottle those 4 lines. And when I was leading this project, I was like, oh, no problem. We'll laser onto the bottle. Everything will be fine. Well, what ended up happening was we lasered so hard onto this bottle that product started leaking out of the bottle. So, and these bottles shipped, like they landed on shelf. So this is like a major quality issue that ideally would never happen, but it happened under my leadership. And so what we had to realize was, okay, it's not as simple as just plug in the recipe in the laser and it'll work. It's fine. We really had to understand how deep we were burning into the bottle, because what these lines do is these are actually for vision impaired people. And so they're actually texturized. And so lines represent shampoo, or we call them straight for shampoo. And then we have circles for conditioner. So SC, right? And this is actually a national or a global thing. So in China, this is already mandated. And in the US, we were trying to implement it. And so this is like really a cool thing to help people that are either blind or have low vision. And we just were like, oh yeah, super easy, super simple, and not really understanding what we were doing, right? And so it took a lot of testing, like definitely came in 2 or 3 weekends in a row, just so we could understand to the science what exact settings were required to create the tactile feel. Because if you just have the lines there and you can't feel it, it's not really doing anything for our low vision consumers. But also making sure that we're not putting the product at risk from a quality standpoint. And I think the scariest part about that was I was so nervous about my boss finding out. And so I had tried to like work the issue like before she even knew about it. And so somebody else told her about the issue. And so that was a huge learning for me, was like, just be upfront when you make that mistake. It's a lot easier to be upfront about it and have your like boss or coworkers work with you to solve the issue than trying to just figure it out on your own before anybody finds out. So, and I'm sure you girls know that a lot better than I did. So keep that in mind.
I think another good lesson from that story too is to not assume things are as simple as they seem. I think that happens a lot in engineering of, oh, it's just a small project and we can do it this way. But it's really important to do your testing that's needed in order to make sure that something small is a bigger problem than you expected. So that's another lesson that I took away from that story, is just always make sure you have the testing in place to make sure your product is good. Rhea, do you have an example?
Yeah, I was thinking about one, and this was pretty much right around about when I started ish. And the way some of my machines work is that there's a series of steps that the machines itself actually have to do. And so just like on a recipe, you finish one step and then it finishes another step and then it finishes another step. On our machines, there are these things called recipes. And each one of those recipes is sort of like a product sensitive thing that our customer is specifically wanting. It wants maybe recipe A followed by recipe B, and then you'll continue down the process that way. So once upon a time, we needed to do a software upgrade on our tool. And one of the first things you do is, just to make sure that all the recipes are saved, you kind of take them and save them on another storage device. You kind of take them off the machine, and then you do your software upgrade so that no matter what happens, those are perfectly saved and there's absolutely no issues that can go on, So I finished up with the software upgrade, or I was there throughout the entire process and everything. And the last step is to eventually put this recipes back on the machine. Well, I accidentally forgot that last part. And so I was just about to leave, and then I thankfully I had someone who was working with me, and he's just like, wait a minute, didn't we forget to actually put the recipes back on the tool and before we hit run? And so what's it called, both of us like ran back to the actual machine and things like that, and we put the recipes back. Thankfully, there weren't too many things waiting on it, because you can imagine if there are things waiting for it to run, then it would have actually caused a little bit of a delay, But thankfully, there was nothing, and we were able to get them back on the tool at the same time. But it involved a lot of figuring out how exactly we're going to get it done quickly before we could see that one product coming down waiting, So. Mm-hmm. It was one of those moments where it's kind of like, wait a minute, I forgot that step, but it just kind of reminded me, do it step by step, slowly, and follow all the rules, So exactly, they're there for a reason, and
yeah. And if there's not rules,
yeah.
Engineers are responsible for coming up with the process and making sure that that doesn't happen in the future too. So, okay, let's see. What types of chemical engineering jobs are available in STEM for students interested in applying for jobs after college? So I know that we talked specifically about your guys' careers, but when you were first out of college trying to find a job, what are just some typical types of jobs that a chemical engineer can do? And I will have Nicole start.
I think we touched on this, but one of the cool things about being an engineer is that you can do a lot of different things. I think any field that you would be interested in could use a chemical engineer. I think it just depends on the level of technical work you want to do versus maybe some more managerial work, or maybe some more standards work or something like that. But I did a lot of interviews and things like that with oil and gas companies when I was kind of going through. That's very typical for chemical engineering, is to work, I think Rachel said, either natural gas or in renewable energies, that sort of a thing. But then they also were recruiting for chemical engineers in medical fields as well. So looking at making products for the medical fields, or going around to different hospitals and looking at their equipment, that kind of a thing. You can also, if you do enjoy more the computer side, a lot of tech companies will take chemical engineers as well, because they have practical knowledge of a process as well as the programming side of it. Pretty much any product. I think we talked a lot about consumer products, but I mean, any product that is on a shelf had to have a chemical engineer in order to get it there. So I think when I started, when I was in high school, my mom was like, what do you want to do? What kind of engineering do you want? And I'm like, best job in the world would be to make ice cream. Like, that was my top tier. Like, if I make it, it's because I'm making ice cream. And they have chemical engineers at Ben and Jerry's. Like, that's it, it's a thing. So think really any field that you're interested in, you can go at it from a chemical engineering lens. It was kind of what I found.
Yeah, and just to,
Go ahead.
or just to add to that too, it's also what's cool about chemical engineering. So I mentioned that I like worked for a rocket company, which like you think rockets, how could that involve chemical engineering? But one of the cool things about chemical engineering is that you can also specify doing like quality. And so in that role, what my job was making sure that the fasteners we were using to bolt the plates together that hold the rocket propellant were to the standard that needed, right? So they could handle the torque and the pressure, and they were the right gauge, the right thickness, the right material, and kind of doing like metallurgy and that kind of stuff, which is like, oh, who would have thought this is chemical, right? And so to hit on Nicole's points, you can go into quality related things. What I talked before about like environmental, that's kind of another avenue of like, hey, what are the gases that our reaction is leaking to the environment? Are these safe? Do they meet the Environmental Protection Agency standards? And so you can also do stuff with like wastewater. So you guys think about all of the waste that goes down the drain when you're drinking from the water fountain or using the bathroom or taking a shower. There's chemical engineers that need to process that water so that we can reuse it. And so it really has a lot of different avenues and there's a lot of different options. So that's the exciting part.
No, I agree exactly. I think the cool thing about chemical engineering is you could like go anywhere with it, you know? So when I was going through all of my different internships as well, the first thing I did was I worked for a chemical fertilizer factory. I was helping them figure out what exactly to use as products and reagents and things like that to be able to make their fertilizer. The second thing I did was I was actually at a energy company where we were trying to make a process as efficient as possible using like thermodynamics and things like that. The third thing, actually, this was a really fun internship. I was actually at a cookies and crackers factory. So I got to go in and every single day I got to smell like snickerdoodle cookies. And just by smelling, I mean, walking in, I could smell, oh, I guess today is a vanilla day, huh? I mean, vanilla wafers day, huh? Type of a thing. So, and now I work in the semiconductor field, you know? So it's like anything you can do. Probably, I mean, like anything that needs to be made or anything that needs to be processed requires some sort of chemical engineering that goes into it. So I think it's really cool that way, you know?
Cool, thanks. I know that the girls need to wrap up soon because of the rest of the FRC team coming in. So I don't know if there's any last minute questions, but I just wanted to say thank you so much for joining us tonight. I know the girls really appreciate it and so do I. So thank you so much. And Linda, I don't know if there's any other questions or.
Any other questions, girls? No, I think this has been very informative. So thank you very much for giving your time tonight for the girls.
You're welcome. And then could you also send me the recording too for us to share with our team as well?
Yep, I think it's in two parts because Andrew had to stop and go from home. So yeah, sort of.
Okay, sounds perfect.
Out.
Okay, well, thanks, guys. We'll head out then, and you guys can have the rest of your meeting. But thanks again.
Thank you. See you.
Thanks
Bye.
so much.
Bye.